So welcome to the tutorial on web scraping, and as an introduction we'll be looking at the web technologies that we'll be using for web scraping, and these are Python libraries such as Beautiful Soup, Selectolax, Selenium, and Playwright. So web scraping is the process of extracting data from websites. It has become an essential skill for businesses and individuals alike. Beautiful Soup is a Python library used for web scraping and allows parsing of HTML and XML documents to extract useful information. And this section of the course will cover the basics of using Beautiful Soup to extract data from the websites of choice. We will need to go over some advanced techniques such as navigating the DOM tree and handling different types of tags. Now this will be facilitated using methods and attributes that come from the Beautiful Soup package, which will be showing you how to install using the pip command. Now Selectolax, similar to Beautiful Soup, but is optimized for speed and memory usage, and we'll be talking about the benefits of it. So this section of the course will cover the basics of using Selectolax to extract data from websites, and we'll also compare it to Beautiful Soup as stated and discuss when to use either of the libraries. Now again, we will show you how to install and get the documentation from the official websites, including the PyPy and the Read the Docs, which do have official documentation. Now, the next technology, Selenium, is a powerful tool for web scraping and allows you to automate interactions with websites. It is often used for tasks such as logging in, filling out forms, and clicking buttons. Essentially, it mimics user interactions. So this section of the course will cover the basics of using Selenium to scrape websites, and we'll also discuss some of the best practices and common pitfalls to avoid. Now, each of these topics I should mention will come with a project to facilitate better understanding of the methods and attributes. Moving on to Playwright, which is relatively a new tool for web scraping that allows you to automate interactions with websites using multiple browsers such as Chrome, Firefox, or Safari. In this section of the course, we'll cover the basics of using Playwright to scrape websites, and we'll also discuss some of the unique features that come with it, such as parallel testing and cross-browser testing. Again, I'll mention that we will cover how to install it and as well as the drivers. I should mention that with Selenium also, it is important to have an understanding of how to install the driver. Now we'll also cover general best practices to follow when web scraping, and this can, well, web scraping, as we stated earlier, is a powerful tool that can provide valuable data. So it is important to follow certain best practices to ensure that your web scraping activities are ethical. So we will also talk further or talk more on this particular topic or this particular issue of the best practices. Now at the end, or rather as the last section, we'll cover advanced web scraping techniques, and this particular section will cover a program that is built using the Beautiful Soup package, and the code will be fetching, or rather the code fetches the source code and uses Beautiful Soup to extract image tags, then uses Pillow and PyTestRack libraries to extract text from the images and regex to filter the text. So this is essentially for removing watermarks from a website, like websites that provide stock photos essentially. So enjoy this tutorial, and I hope you learn as much as you can. Welcome to the tutorial on mastering web scraping using Python. Python is a popular programming language, of course, and can be used for multiple fields such as data science, web dev, and automation. So the first step, which will be installing the Python language, we'll be going to the python.org/downloads website. Uh, Once you go to the site, look for the appropriate version of Python 3 for your OS, and you can select uh, the Windows, Mac OS, or Linux version based on your operating system. If you are unsure which version to choose, select the Windows x86 64 executable installer for Windows or the Mac OS 64-bit installer for Mac OS. As you can see the different OSs here. So once the download is complete, we won't be installing it in this case since we already have it on our system. But once it's installed, or once the download is complete, you open the download file and run the installer and follow the process. After which you can type in the Python 3 version which you've seen I've just done and press enter to verify that Python 3 has been installed. So in this section, we'll be discussing the important role that web development technologies such as HTTP, HTML, XML, JavaScript, JSON, and CSS play in web scraping. So instead of the manual process of copy pasting, web scraping allows you to extract data in a scalable and automated way. However, to begin with, the first process before starting any program should be like a best practice is to get a virtual environment which will not interfere with already installed packages in your system. So in this case, we'll be moving into the documents directory using the cd command and creating a folder using the make directory command, the shell make directory command. So we'll call our folder project scraper, after which we'll enter that folder with the cd command, and after which we'll create our virtual environment using the Python 3.1 make virtual environment, and we'll call our virtual environment venv. Then using the source command, we'll activate our virtual environment through the venv, which is our name, being active. So for personal knowledge, there is an extension command to open your VS program, which is the code.command, after which it will open a window for your program. So after that, let's begin with our introduction into web scraping, which is the process of extracting data from websites in a more automated way, as I mentioned earlier. This is an essential skill for developers, to be honest. So using the Python language, web scraping has never been easier. Python libraries such as Beautiful Soup and Selenium provide powerful tools to extract data from websites with ease. Of course, there are more libraries which we'll be talking about next or further into this course. But first, to master web scraping using Python, one must have a very good understanding of web dev technologies such as the HTTP or Hypertext Transfer Protocol, HTML, XML, JavaScript, JSON, and CSS, all which play a vital role in web scraping. Technologies such as HTML and CSS are essential in knowing how to identify structure of a website's code and make it much easier to extract data accurately. Additionally, learning regular expressions or regex can help automate the process of extracting data. So let's move on to our HTTP page. Essentially, this page will be talking about the Hypertext Transfer Protocol, which as mentioned earlier, is a protocol used by web servers and browsers to exchange information. HTTP operates between clients and servers in a request-response protocol. So you can use the Python request library to send an HTTP GET request to a website and retrieve its response status code. We'll be looking further on how to install the request library using the pip command. But in this case, I'll be showing you how to get the status code after making a request to a website. Our website in this case will be Wikipedia, and we'll use the request.get method, and after which we'll be placing that response in its own variable, the status code variable, and printing the status code command. Now, this particular code essentially, or this particular 3 lines of code essentially are just printing the status code after we make a request to the Wikipedia page. We can also do it for the Amazon page. However, the Amazon page does check for cookies and your user agent as opposed to the Wikipedia page. So that's why I've used it in the example as opposed to the Amazon page. So the 200 request, or the 200 code that we got from the Wikipedia page, essentially means the request was successful. We have other codes which you can research, 500, 300, and 400. But in this case, our request to the server was okay and returned our HTML code for the page, the Wikipedia page. So for those of you who have ever wondered how web pages are created, well, it all starts with HTML. HTML is a standard markup language for creating web pages. As mentioned earlier, it provides structure and content of web pages. HTML consists of elements and attributes, as mentioned, and HTML defines the structure of a web page such as headers, paragraphs, and images. HTML attributes define the characteristics of an element. In this example, we are using HTML to create a web page with a title, heading, and paragraph elements. The title element provides a title of a web page which appears in the browser tab. The heading element is used to create the heading for the main content of the page, and the paragraph element is used to add text to the page. HTML is a fundamental building block of web development. It is easy to learn and use and provides developers with a lot. So moving on to the HTML elements that are used to define the structure and the content of a page. So this can include everything from text and images to tables and forms. So in the first example here, we have some commonly used HTML elements and attributes. To begin with, we have the div element. This element is used to create divisions or sections on a web page. This makes it easy to organize content and help create a visually pleasing layout. Next, we have the image element, and which this element is used to insert images on a web page. Images are a powerful way to convey information. After which we have the href attribute. The attribute is used to link to other web pages or resources. Adding links is an essential part of web development. And lastly, we have the alt attribute, which is used to define the alternate text. So moving on to the XML, or extensible markup language, which is similar to HTML but is used for data interchange between computers on the internet. XML is a markup language designed to and transport data. Here's an example of an XML file with book elements, each with a title, author, and year attributes. So next would be the JavaScript, or a JavaScript language, which is a scripting language used for web interactivity. It creates animations, manipulates HTML and CSS styles, and performs client-side validation. Essentially, JavaScript is also very important for web scraping because you have to factor it into your code. So as an example here, we have a web page which has a script tag at the bottom, whereby we select the div element using the query selector method and assign it to the div variable, after which we add an event listener using the add event listener method, which waits for a click event.
and when it's clicked inside the anonymous function, or rather when it's clicked, the anonymous function will be executed. Inside it, we have some code that will change the background color of the div element to red by editing the background color. So moving on to JSON. JSON, or JavaScript Object Notation, is a lightweight data interchange format that's easy to read and write. It's text-based format used to transmit data objects consisting of attribute value pairs. So here is an example of employee data in JSON format with the first name, last name, and age attributes. As you can see, this particular JSON is an employee, which essentially has a list of employees. So this section will be covering data finding techniques, and as you can see, we have a normal Google page here at the beginning homepage. Really, data has become increasingly important to businesses and individuals alike. Finding and extracting data from the web has become a crucial skill in today's digital age, and luckily there are several techniques that you can use to extract data from a website. So we'll be covering 4 very important techniques, and the most common of which is the view page source. We'll also be looking at the dev tools or the developer tools, and the robots.txt file, as well as the sitemaps.xml. So let's get started with the beginning, which is the HTML page source. So the HTML page source is as mentioned, one of the most common techniques. Is essentially viewing the HTML source code of the web page. This is quick and easy, This is a quick and easy way to extract data from a web page. Most web browsers have a view page source option in the context menu that allows you to see the HTML code underlying the page. You can use this method to extract data by searching for specific elements in the code and to scrape the entire page. So another technique is using the developer tools, which are almost always included in modern web browsers such as Google Chrome, Mozilla Firefox, Safari, and Microsoft Edge. These tools are up when the user right-clicks on an element and selects Inspect, as will be seen in a couple. These tools allow you to inspect the pages, HTML, CSS, and JavaScript, as well as monitoring network traffic and analyzing performance. These tools can be used to extract data by selecting the specific element in the HTML tree, as well as copying any inner HTML text. Now, this is a really important part for both if you want to use web scraping with APIs as well, instead of just getting the HTML as well. So we can see here the inspect tool, or rather us right clicking the inspect button, and here we can see the various things we've just talked about, the elements as well as the console. And if you click on the 2 arrows, you can see the other various things such as the network, the performance, sources, etc. So after that, we can look at the last 2 data finding techniques, which are sitemaps and robots.txt file. The sitemaps are essentially a list of all the pages on a website in a structured format. You can often find the sitemap by appending the sitemap.xml to the end of the website's URL. By reviewing the sitemap, you can quickly determine the structure of the website and identify where the data you're looking for is located. Finally, you can also use a website's robot.txt file. And a robots.txt file is a file that tells crawlers like Google's bot which pages the owner of a website does not want to be crawled. You can find the robots.txt file by adding the robots.txt to the end of the website URL, just like sitemaps.xml. By reviewing this file, you can get insights into the website structure and which pages the owner is attempting to restrict access to. So as you can see here, we have the robots.txt file, which we've appended onto the website URL. And sorry about that. And by using these techniques, you can easily extract data you need from these websites, whether you're an individual looking for personal data or otherwise. So let's go over the common Python library Beautiful Soup. Beautiful Soup, as we know, is a popular Python library that is used for web scraping. And in this particular section, we'll use it to extract data from HTML pages. So let's begin with how to install it. So let's go over onto a website for Beautiful Soup. As you can see, an easy pip install Beautiful Soup command is at the top page. You can copy that into your terminal, which will install the package. And if you want to further your knowledge about Beautiful Soup, you can go onto the PyPy page. Of course, this PyPy page has a lot of details already, but if you want more details, you can go to the Beautiful Soup 4.read the docs, and essentially you have various methods of installing it, of troubleshooting it as well. You can see making soup, the kind of objects that you'll see, the methods, traversing down the tree, everything that you need to learn about Beautiful Soup to scrape a web page or to move down the HTML document. So the first thing, which is best practice as we stated earlier, was to create a virtual environment. The virtual environment is necessary so as to prevent conflicts with other library versions on your system. So once activated, the command that you copied from the PyPy website can be installed via the terminal or the command line if you're on Windows. And by running the installation command, you get all the necessary packages in your virtual environment folder. So Beautiful Soup offers a variety of HTML parsers, which is what we'll be looking at in this section. Now, the first parser we'll be looking at is what comes in with Beautiful Soup, which is the HTML.parser, which is wrapped by quotation marks as a string. And this Python, we can see its use in this particular tutorial. What we got from the presentation, and all you'll need to do is import the Beautiful Soup library from BS4, which is a folder that it comes in when you install it with pip. And if you, for instance, we have a HTML doc variable with some HTML as a string, and we want to pass it and see what elements it has. So as you can see, we create a Beautiful Soup instance with the HTML doc variable and a HTML.parser as our parser, and we want to see what the paragraph element has, or what is contained in the paragraph element. So after So whatever we'll print out will be the hello world string, which was contained in our beautiful soup, in our paragraph element. So that is that example one. And the second parser is LXML, which is a C-based parser known for its speed and ability to handle large documents. It requires the LXML library to be installed, which can be done using using the pip command. It supports both XML and HTML parsing and can even parse broken documents. Now, so the first thing is to go to the PyPy page, and in this case we'll be using the pip command to install it. After which we'll try out this example here using a beautiful soup instance with our LXML library. So you can simply copy the pip install LXML and place it into your terminal or your command prompt if you're using Windows once more. And as we did with html.parser, we'll put it into our beautiful soup instance, and it will again get the string in the p element or the paragraph element. So the next parser is html5lib, and this is a pure Python implementation and requires that the HTML5 library to be installed, which we'll be doing so in a few. The good thing of it is that it can parse broken HTML or unclosed or mismatched elements. So on the PyPy website, you can just go and just essentially install it with the pip command, which is at the top, after which you can use it as your parser in the beautiful soup instance, and it will print out what you require. In this case is the p tag that we did earlier on. So the next section is accessing HTML elements using beautiful soup. So these are essentially locators. As we saw earlier in the website, if you go to the Read the Docs website, you have a brief introduction or usage of each and every one of the methods, as well as the attributes of the beautiful soup instance that you create. So the next section is accessing HTML elements using beautiful soup, and these are essentially methods or locators. So once you have beautiful soup installed, we can use beautiful soup to access HTML elements, and the first step is to pass the HTML content, as we've seen, using the beautiful soup instance by passing to it the HTML content and a parser type as well. This is passed to the instance. So then we can access various attributes and methods to locate individual elements. So the first method is a find method, and the second is a find all method, each of which will be given a tag and an attribute. The reason we have the class with an underscore attribute is because class is already it's a keyword that has already been taken by Python to create classes or objects in Python by the Python language or the Python parser. The second is the select method. The select method is another way to find elements. This uses CSS selectors. So as you can see in this one, we want to locate all paragraph elements that are inside a div element and have a class attribute of container. And we'll be going through these examples in a few minutes, so in a few seconds maybe. So the get method is the other one, which is used to retrieve the value of a specific attribute for an element. For instance, the value of the href attribute for an A element, and all this can be chained together, a builder method of some sort. So the chain method is a technique that involves using multiple methods in the same line of code. So like for this next one, we want to find the first h1 element with a class of title and access its text content using chaining methods. And as you can see here, we use soup.find, the beautiful soup instance dot the find method, and to the we pass the h1 tag to the method as well as the attribute class of title. And then we pass it, we use the dot notation and pass to it the text attribute. So the path here refers to the location of an element within the HTML document, and we have an example. So we're going to be looking at the examples that we've just looked at in the section on accessing elements using the methods or locators. So the first thing is to create a beautiful soup module using the touch command, bs4 touch bs4 locators.py. So bs4 locators.py will be our module, and we'll use this module to contain all, or rather to house all our examples that we've just looked at. So this is just to show you practically what we'll get, or rather what will be returned from a dummy HTML document. So our HTML document will contain a dummy HTML document structure, or rather HTML tree structure with a header, body, and several inner elements. So we'll using the beautiful soup instance that we'll create, and we'll pass in to the beautiful soup instance the HTML doc, which is a variable, as well as our parser, which is a HTML.parser. Of course, you could use the LXML parser if you wish. If you have probably a larger document which you want to parse a little bit faster. Now the first method we'll be using is our find method, which will come from our soup instance, and we'll be looking for the A element, or rather the P element, with a class value, a class attribute value of article. The next is the find all method, which we'll be looking for all A tags which do include a href attribute. And the third is using the select method. Again, select is for CSS selectors. So as you can see, the div.container p tag. So essentially, we are looking for a p tag that is contained inside a div with the class attribute of container, class attribute value of container. And finally, we do have the find, which we are looking for we're looking for the first A tag, and we want to see what href attribute value it has. Then we have another find, which in this case we're using the chaining method, and we want to find the h1 tag with a class attribute value of title and get its text. So we're appending .text to it. And lastly, we're looking for the first A element, and in this case we want to find all the parents of the A element. So we're using a generator expression to get all the A tag, all the parents of the A tag, and we're using the find parents method. Then we append all the parents to the A tag itself, and then we print it. So let's see the output of all these examples. As you can see, we're using the Python bs4 locators.py, and you can see we've printed everything works as it should be. And at the bottom you can see document HTML. The last thing that we printed again was appended. All the parents to the A tag were appended ahead of the A tag. It came out as a list. So lastly, we'll be looking at a project to really get you into, or to get you to understand what we've been looking at, all the methods, all the attributes of Beautiful Soup. And we'll also be looking at how to make requests to our website as well. So in this section, we'll be discussing Python code that retrieves both internal and external links of a web page, in this case Wikipedia, and selects a random external link while repeating the process with the new link until there are no more external links to follow. Now we won't let it be completely recursive since we do not want to overload the Wikipedia servers, as I will break the rules of the robots.txt file, or will be unfair to them, because so the first thing is to create, as usual, is to create the module. We'll call it wikilinks.py, and and we'll head into the wikilinks file and begin by importing the necessary libraries. So we'll go into our wikilinks module, and the first thing is to import all our necessary libraries. And so our first is the HTTP request library. The second line of code is importing the beautiful soup library, which is used for web scraping. The third is the RE library, which is a regular expression library for the Python programming language. The fourth line is importing the time library, which provides a set of functions to time any Python program. And the fifth line is the random library. So the following line after that is code that defines an empty set called pages. This set will store the pages we visited to prevent duplicates in the program. The getLinks function that is defined next takes in a single parameter called page URL. The global keyword in the function makes the pages set accessible globally. The following line defines a user agent header to imitate a browser. This is done to avoid being blocked by servers or treated as bots. Then the code adds a delay using, sorry about that. So the user agent first to imitate a browser. This, as I mentioned, will prevent us from getting blocked. So let's close that keyword value. And then we have our following line, which using the Python's time library, we add code that will delay the code to avoid clogging the server. And after that, an HTTP request is made with headers, and the response is stored in a variable called response. Now the next line of code is a beautiful soup instance to parse the HTML content of the requested web page. We're using the HTML.parser. Again, you could use the LXML parser if you want to. Then we have a try except block that prints the heading, the first paragraph, the edit link, the Wikipedia page we are visiting. And if a page is missing any of these elements, it will raise an attribute error, as we can see in the attribute block. And we'll print out a statement that it's missing that. So after that, we create a for loop, and the for loop uses beautiful soup's find all method to search for all A elements or A tags on a Wikipedia page. It then searches for the href that starts with wiki. After checking for duplicates, it stores the new URL in the new page variable, and the set pages is then updated with the new page. Now, so after that, the function call, and at the end of the block recursively calls getLinks with new URL. And lastly, if the block ends up in false, then the function is called again with an empty string. And after that, we can create an if statement, checking if name is equals to the main program, the main module, we start the getLinks file, or rather getLinks function. And as you can see, it's printing each page recursively. And again, if it's missing, we're using our try catch block, it will tell us this page is missing something and it will continue to the next.
So in this section, we'll be covering Selectolax. Selectolax is somewhat more similar than, or rather, is more similar than Beautiful Soup than any other Python libraries, Python library framework that is used for web scraping. It is like Beautiful Soup used for parsing HTML and XML data. However, Selectolax does have some benefits over other parsing libraries, such as Beautiful Soup, and this include speed, memory usage, object-oriented interface, error handling, security, and compatibility. Now, on the point of speed, Selectolax is considerably faster than most other parsing libraries. Selectolax speed advantage in parsing HTML documents is due to a lower memory usage and increased efficiency in parsing operations. On memory usage, Selectolax has a lower memory usage compared to other parsing libraries that have to load the entire parsed document into memory. This makes Selectolax a better choice for applications that require frequent parsing of large documents. And, and an object-oriented interface, that point essentially means that Selectolax uses an object-oriented interface that makes it easy to navigate and modify parsed HTML documents. This interface allows for interacting with elements and attributes of HTML and XML documents using both dot notation and string-based methods. So on the point of error handling, Selectolax has strict HTML validation rules and will raise an error whenever it detects invalid HTML code. So this would be probably very useful to catch errors early in the development cycle, and can reduce development time. On security, Selectolax is more secure than other libraries because it doesn't allow direct string manipulation or execution. This feature makes it difficult for malicious code or scripts to be injected into a Selectolax-based application. So finally, on the issue of compatibility, Selectolax works with both Python 2 and Python 3 and is platform agnostic. This means that developers can use Selectolax on a wide range of platforms and operating systems. Okay, so the first thing is we're going to be looking at the installation. I will begin with the pypy.org page, and we can see all we need to do is copy the pip install Selectolax. The pypy.org does have installation steps as well as error handling, just the basic, or rather the bare minimum. However, if you do want an in-depth understanding of the package, you can have a look at the read the docs, or rather Selectolax read the docs. But the PyPy package does have quite a bit as well. So looking at the Selectolax.read the docs, we do have HTML parser, node selector, just everything that really is required for understanding the package. And again, that's selectolax.readthedocs.io. So getting into Selectolax, as mentioned earlier, it is designed to make web scraping a breeze with a wealth of features for parsing HTML and selecting specific elements. Again, to begin with, you have to install it using the pip command with pip install Selectolax, as mentioned earlier. And once installed, you can start using its methods and art. So again, you should remember that before using it, it's best practice to create a virtual environment, again using the Python 3 point whatever your version is, with the M flag and virtual environment or VNV and the name of your virtual environment. So moving on to the next section, which will be the methods and attributes that we're going to be using with Selectolax. And to begin with, remember that Selectolax is used for parsing both HTML or an XML document and returns an HTML instance, which contains a tree-like data structure of the parsed document that can be searched for specific elements. So the most commonly used method is the parse method. So the parse method is very essential for returning an HTML instance. Now, this instance will assist in breaking down the tree into what is necessary. And the next is the CSS method, which selects elements from the parse document using CSS selectors, returning a list of HTML instances that match the selector. And in both of these, we do have an example. Both of these examples will be explored at the end of the presentation. And like Beautiful Soup, you have to get the HTML parser, which you pass in the HTML string, and this essentially gives you an instance of the HTML elements as mentioned. And then from there you can use the various methods. So the next is the XPath method, which is another method that Selectolax supports, and this method selects elements from the parsed document using XPath expressions. Now the XPath language is something that you can cover a little bit more in depth. It's similar to regex, would require a presentation on its own, but the syntax is not very difficult. So this essentially will return a list of HTML element instances as well. The next is the find first method, which is another commonly used method in Selectolax, and this method allows users to find the first element that matches a CSS selector or XPath expression and returns again a HTML element instance. Excuse me. And again, we do have examples. So the next is the select method, which allows users to select child elements of an HTML instance, returning a list of child HTML instances that match the CSS selector. And the next is the HTML attribute. Now this attribute, amongst many others, the HTML attribute, for example, returns the parsed HTML or XML document of the string, so the entire HTML document. And again, we do have examples for both, which again I'll say will be covered at the end of the presentation. So, yeah. So the next section, or the next attribute will be the text attribute, and simply put, this attribute returns the text content of an HTML instance. So like in this particular example, we are looking for the list item, the text that is contained by the list tag or the list element, and we're using a loop to get it. And the next will be the tag attribute, which returns the tag the tag name of an HTML instance, and it returns an HTML instance essentially. which is either the H2 element or whichever other whichever other HTML element that you need, whether it's a paragraph element or in this case the H2 element or the heading. It will return it to the HTML instance. So the attributes the attributes attribute essentially, as you can guess, this attribute returns a dictionary of attributes and their values of an HTML instance. So for instance, in this case, we want the input, the elements that are in the input tag or the input element. So for instance, we'll have the value tag. If you have an HTML document that has probably an input that is the user requires to put in their name or probably their date of birth, the value will contain either the date or it will contain their actual name, whatever they input in. So given that we've gone through these most commonly used methods and attributes, we can move on to the next section, or the examples. Now to start us off, again, we have to begin with the pip install, and in this case you can see at the end, or at the beginning of the line, we have our v and v in parentheses. So we are working in a virtual environment, and we've installed our Selectolax package into the virtual environment, v slash lib directory. Okay, so using the touch command, we'll create our file, or rather our module. Names are interchangeable, and as we do that, once that is complete, we can import the HTML parser. We also have the selector, which again is also an instance, or rather gives you an instance of the HTML document. So we'll create a dummy HTML document, as we can see, and we'll place our HTML parser instance, or our HTML element instance, and name it doc. We'll pass our HTML instance into the doc variable, and as we saw in the beginning, we'll start off with the doc.css method, and we're trying to get any input with the element, or rather with the attribute of type is equals to text, and we use a for loop to print every one that we find. Then the next is the doc.css, again that method, and in this case we're looking for a div with the class of content, and all these are CSS selectors. And again we have another method which is a css.fast, and for that method we're looking for the head for the h1 tag and printing out the tag itself. And lastly, we're looking for the fast CSS input and the input dot attributes. So we're looking for all the attributes in the fast input tag that we see. And if you run it using the Python selectolax.py, you can see it outputs each individual method, or rather each individual all the print statements that we have coded into this file. Now if you notice, we didn't use it in every one that we used in the previous one. It's more an issue of preference, although you can go through the docs and really get into Selectolax because it is a powerful library. So now let's look at this project on getting our links using Selectolax from the Wikipedia page. So lastly, we'll be looking at a project to further understanding of the Selectolax library. And this project will be scraping links from the Wikipedia page. So to start us off, let's create a wikilinker.py file using the touch command, and the first few lines are the necessary libraries, which include the requests, HTML parser, the array, datetime, random, and URL parse module. Now we start off with the random.seed function, which is used to initialize the random number generator. And next we have a getInternalLinks function, which passed into it is the HTML as well as the include URL parameters. And now the URL parse.scheme is used to extract the URL scheme value, which is HTTP or HTTPS. And the netlock, using dot notation again, is used to extract the network location. An empty list, as we saw, is internal links is created to store all internal links. The tree creates a Selectolax tree structure from the HTML parameter, passes the HTML page contents, and makes it passable by the following for loop. A for loop is used to iterate over all A elements of the HTML, and the next few lines are used to retrieve the href attribute. The if statement checks for href values that begin with a /, which indicates a relative link. Next, full link is initialized to include URL plus the href variables, or just the href. The last if statement checks for duplicate links and appends only unique links to the internal links list. Finally, the function links list. After that, we have another function, getExternalLinks, which we pass into it the HTML and exclude and exclude URL. So with the key difference being that it is focused on retrieving external links. So external links is entered to exclude a particular link that matches the network location. The exclude URL's network location using URL parse function. A list external links is created to store all external links. Again, tree creates a Selectolax tree structure from the HTML parameter. The for loop is used to iterate over all A elements of the HTML and retrieve the href attribute. The if statement first checks for the links that start with a www or http and includes links that match the exclude URL. The last if statement checks for duplicate links. Finally, the function returns the external links list. The other function is getRandomExternalLinks, which we pass into the starting page parameter. Now the starting page parameter is the starting URL. The function tries to open a page by creating a request object with headers via request.get function. If page is not open, then an exception is raised, likely a request exception. A soup object is created from the HTML contents passed via HTML parser method. A list of external links is obtained via the getExternalLinks method. If the external links list is empty, then the getExternalLinks method is used to retrieve a list of internal links. If both external links and internal links are empty, then the code prints an appropriate message and returns none. So the function returns a random external link via choice function or a recursive call to itself via random internal link. And we can see the else there, random.choice, using the random library that we imported. Now, the last is the follow external only. This function starts when a program is run. It accepts the start inside parameter, which is the starting URL. The function uses getRandomExternalLink method to find a random external link for the given status. If the function returns a valid external link, the function prints it. So as you can see, we've run it using the Python command, and it is getting all external links. So the next section will be about Selenium, and Selenium is an open source web-based automation tool for simulating browser interactions and performing automated testing. With Selenium installed using the pip command line, installation, as we'll see, users can access a vast range of methods and attributes to interact with web elements, as well as automate tasks and control the browser. The package's primary interface is called WebDriver, which allows users to navigate, interact with elements, and control the browser's behavior. One of the most notable features is numerous methods used to locate web page elements such as the ID, name, class name, link text, CSS selectors, my favorite, and especially XPath. Selenium automation also includes action and attribute trains to simulate user input and attribute properties and attributes properties reading or modification. So let's begin with Selenium and simplify our automation tasks. So the first thing is to head over to either the read the docs or the PyPy page. Right here we're going to look at the read the docs page, readthedocs.io, and this not only gives you the basic installation for various for the actual Python Selenium package, but also gives you the various methods that you have access to once you install the package. You can also get further documentation on the selenium.dev website, and as you can see, it's language agnostic with Java, JavaScript, Python, C Python, etc. Ruby, I mean, and you can use it really as a reference, as opposed to the read the docs web page. And you can see also gives you info about the supported web browsers, which is very important. In a few, we'll be looking at how to install the Chromium package, which we'll be using. So next up will be Selenium Wire, and you may ask why would you use Selenium Wire? Now, Selenium Wire is important because it provides a more granular and precise approach to web automation than many other automation tools, and it is a Python library. As you can see, you can install it with the pip command, and really it extends and enhances the capabilities of Selenium WebDriver in automating web browser interactions. It provides a simple and powerful Python API for interacting with network traffic generated during web page requests and responses. So a very important aspect of it is that you can accurately simulate, or rather the accurate simulation of web browser behavior. This provides a more accurate simulation of browser behavior compared to other automation tools, as it captures and processes network traffic in real time. This is important for testing web applications that rely on specific network behaviors, i.e., AJAX requests and other asynchronous data transfers. So other special features or useful features is easy inspection of network traffic, and with Selenium you can easily inspect the network traffic generated during web page interactions. This allows you to debug network related issues. Another is seamless integration with Selenium driver, which is very important, and Selenium Wire seamlessly integrates with Selenium WebDriver, allowing you to easily switch between automating web browser interactions and analyzing network traffic. And the last will be proxy support. Selenium Wire supports the use of proxies, which can be useful for testing web applications that have geographic restrictions or that require interaction with restricted networks. And one more would be interception of HTTP requests. And this is useful for testing web applications that require interactions with APIs or for automating
tasks that involve scraping data from websites. So next special thing that you'll need, or a very necessary thing, is to download the Chrome driver, or the Chromium extension. Excuse me. So you should just look for your whatever your Chrome browser version is, and download the appropriate version. I'm downloading the 12 because that is my Chrome browser version. And look for the system, either Linux, Mac, or Windows. I'm using the Mac 64.zip, and wait for the download. And once it's complete, head over to your downloads tab. Now, based on where you want to store it, really, because you'll be referencing it in your code. So in my case, I'll be putting it in my bin folder, and that's what I'll be referencing in my code, as you'll see further on when I'm using my WebDriver instance. As you can see, that's a path users mark bin, which you'll be seeing in later sections. So let's begin with Selenium, with that all in place. So again, as you can see, what we already talked about, being open source, automated, etc. The pip install Selenium command, and once installed, it offers an array of methods and attributes which help in automated tasks as well as controlling the browser, in addition to accessing or interacting with various web elements on the browser. Now, the WebDriver is the primary interface used to control a web browser. As we talked about earlier, it provides a set of methods that allow users to navigate to web pages, interact with elements, and control the browser behavior. Now, let's look at all the methods and attributes of the Python Selenium package. Now, these methods are important, and if you go to the documentation, as we've seen, there are quite a few, but we'll be looking at the most commonly used methods and attributes of the package. Just to mention a few, we'd have the find element by ID method. We'd have also the find element by name, by class name, by tag name, by link text, partial link text, and those are just a few of the most common ones that you'll be seeing in this section. We also do have the actions and the attribute chains. So as you can see, we have a short example here of how to instantiate the Chrome driver or the Chrome extension through a Chrome object using the WebDriver.Chrome. The dot notation, this initializes the Chrome driver, after which, using the get method from the driver instance, we just pass in the URL, or the URL, so as to navigate to the website. Sorry, and have a brief introduction on locators, and mentioned a few locators earlier on. And we can begin with by name. So the find element by name method is used to locate an element using its name attribute. We have an example here using the driver instance. and we are looking for the name, which we'll see exactly how it works in just a few. So we can see here we have an example, an input attribute with the name attribute, the value being username. So the next example, as you can see, the first thing is to import the Selenium or import the WebDriver from the Selenium package and instantiate the Chrome class using the WebDriver.Chrome, or rather using the Chrome method. After which we use the get method from the driver and pass in our user, or rather our the page URL that we want, and we look using the find element by name. We're looking for a name value of username. After which we enter using the send keys method. We enter our login credential or our login username, and after that we look for the button or the input button using the CSS selector, and we're looking for an input with the attribute type, which is a particular button. So as mentioned, this example essentially finds the element by name, then searches, and then once the username input element has been located using the send keys method, it's called to enter the value example user, just as I mentioned. So another particular method that I find, or a locator that I find somewhat confusing, is by link text. And by link text essentially looks for the text that is in an A tag, or mostly in an A tag that you want to navigate to so as to scrape that page. So we do have an example here with a dummy HTML document within a body tag, within a UL tag. So in this example, the find element link text method is used to search for the element whose visible link text is about. So once the about link element has been located, the click method is called to simulate the user clicking on the link, and this will take the user to the about page if it exists. Note that the find element by link text method is case sensitive and therefore will only find an exact match for the specific link text. If there are multiple links with the same link text, this method will only return the first matching link element. So that is something that you have to be careful about. Make sure that whatever you pass to the find element by link text method has to be case sensitive. So whenever you're on the page source or the dev tools, when you're looking through the HTML, make sure that you get the right case sensitive text. So I think we covered that. By class name is pretty self-explanatory and clear. By partial link text, so find element by partial link text, and this method is used to locate a link element using a partial match of its link text. Now this is also case sensitive, but it doesn't have to be the full link text. By CSS selector, as you can see here in the example, we are using the pound sign to look for the ID with a value of example ID, and the dot to show we're looking for a class attribute with a value of example class. Now let's have a look at the by XPath. So looking into the XPath method, The XPath method allows you to locate HTML method elements using the XPath expression. So the XPath language is used well, and in this example, the first thing, of course, is to import the Selenium WebDriver module and initialize a Chrome driver. Excuse me. We can then navigate to a web page using the find element by XPath, the XPath method, to locate a button element on the page using an XPath expression. The XPath expression selects all the button elements with a class attribute of that, and once we have located the button element, we click using the click method. So let's look at, after XPath, let's look at action chains. And action chains are a way to automate the simulation of complex user interactions such as mouse movements, clicks, and scrolling. It involves performing a sequence of actions, building up a chain of actions and events which can then be executed by the website. So the action chains class in Selenium Python enables users to create a chain of events that the website can execute. So suppose you are automating the testing of a web page that requires the user to log in. The user needs to fill in their email, password, and click the login button. So first things first is you need to locate the email input, and once you find it, you then use the send keys method to enter the email address. So as you can see, we have an example here, and in this code, we first located the email and password input fields as mentioned. We then created the action chain that is the send keys method to input both the inputs for email and password, and finally we use the click method to click the login button to log into the website. And actions.perform is the most and final important step that will execute all the commands for the particular action. So moving on to attributes, and attributes are properties of a web element that can be read or modified by Selenium. Some of the commonly used attributes in Selenium are retrieving the text content of the element and getting or setting the value of an attribute href. And as you can see, we have an example whereby we are finding an element by the ID value, such as example ID. We then retrieve the text of the element or the text content of the element and then print it, and then again we get the get attribute of the href value, and that is going to be the link. And if you further move on, you can click a particular, or rather you can use that link to go into a new browser context and execute that. So next we'll be going further to get a further understanding of Selenium using a project, and this project will be getting all odds from a betting site called Betway. And the reason I chose this project is really to illustrate everything from the putting in your headers and other options or other properties that will help you get to interact with the website and get whatever data. So what will this really entail? So the code will be an example of web scraping using Python Selenium package, and the goal of the code is to get live sports betting odds from a particular website. The code uses Selenium WebDriver and Chrome driver to control a web browser, and the Beautiful Soup library to parse the HTML content of the website. It also uses various methods such as wait for element and get status to wait for the web elements to be present before performing any action on them. The code then navigates to the live sports betting page, selects the both teams to score market, and scrapes the betting odds for all available matches on the page. The script data is then appended to a list and printed at the end of the code. The code also has some optional features like login and random wait times to simulate a real user's interaction with the website. Now, the random wait times are really important as some sites do monitor how a user interacts so as to know if this user is a bot or a real user. So it's necessary for you to put those particular things. We'll also be seeing other particular uh, other like the headers and other options, as I mentioned earlier, that will prevent us from being blocked. There are of course other methods such as using proxies, but we'll not be covering that here as they are a bit more complex, but in future we will. So let's get started. So the first thing is, of course, to install both Selenium and Selenium Wire, because that's what we'll be using in this particular module. And once done, we can begin using it. Let's just wait for it. And using the touch command, we'll create our module. We'll call it oddscraper.py. And we can start code. So the code implementation of the web scraper, as I mentioned, extracts live sports betting odds. And so I'll give you a line-by-line explanation of what the Python code will be doing. And the code will begin by importing the necessary dependencies and libraries, including Selenium, Beautiful Soup, and others. After the imports, a variable is declared which will hold the number of times a web page should be retried in case of connection errors. The function getStatus is defined to extract the status code of the HTTP request to the website. It accepts an argument which is the log of the network activity. The next function, browser, is defined to set up the Chrome driver for automated browsing. It uses the webdriver.chrome method to start a new browser window and accesses the web page using the get method. Another function, waitForElement, is created to find a web element by XPath. It takes the Selenium driver instance and the XPath of the web element as input arguments. It uses the WebDriver wait method to wait until the web element is visible. And using the presence of element located method, now the main function betScrapingGen is defined, which is responsible for scraping live sports betting odds. It calls the browser function to initialize the Selenium driver and navigate to the driver the desired URL. After navigating to the website, the code waits for the page to load by making at most 15 attempts to get the server's response status code. And once the website loads, the script navigates to the both teams score market, scrapes the betting odds for all available matches on the page, and appends the scraped data to a list. Now I've jumped a little bit ahead, but that was the explanation. But going back, you can see the browser function, which takes in the URL, and we add all the necessary options, and the code does come with the course, so you can have a look at it. And as you can see, it's necessary to add the user agent to mimic a browser. And there is the path that I was talking about for the Chrome driver, which will be part of the instance so as to have access to the Chrome browser. And it will be passed into a service instance. And as I mentioned, will be part of the Chrome or the WebDriver.Chrome instance. So once we have that, we use the get method and pass in the URL which we passed into the browser function, and we'll return the driver. And we come to wait for element, which again is created to find a web element by XPath. So the try exception block is necessary so as to ensure that if we do not get the element after using the WebDriver wait, we can retry it. And this will be based on the number of retries that we set above. And the while loop will test if we have if we've gone past 3 retries, after which it will. So moving on to the bed scraping gen, we're giving it a range of 15, and essentially we're using the getLog method. Really, this is to test if we've gotten a 200 response code from the website. So as if we do get a 200 or between a 200 and 404 request code, we'll break and move into the next section of the function. Sorry, I'd forgotten to put in the driver instance. Sorry, the browser instance. So again, if we do not get a response code between, or rather status code between 200 and 404, we'll close the browser. Shouldn't forget to close the browser. So specifically, if we do get a 200 request as well, we will move into the next section, which will be actually collecting, or rather navigating through various parts of the web page and getting there and accessing, or rather clicking the buttons that we want to. In this case, we'll be clicking on a drop-down page, or rather a drop-down button to get the particular market, which is both teams score. Both teams to score. Now we saw earlier we had a wait for element function, which returns the actual element, and if we do not get, if after a number of retries we don't get it, we close the browser again and print out a statement of unable to locate the element.
and we do the same for the market. Okay, sorry, the drop down was just a drop down, and the drop down was just a drop down button, and the market is actually the both teams to score button, both teams to score button, or the both teams to score option. After which, this is where we'll need the beautiful soup, and that's why we're getting the page source itself using the page source attribute, the driver.page source attribute. And we're using the LXML parser, which in earlier sections we did install using the pip command and pass it in as a string. And using the soup.find, we're looking for each and every, or the div element that holds the entire, all the odds. Then after which we're looking for div with a class attribute of event row. Again, we're using an underscore after class because the class keyword has been taken by the Python for defining classes or objects. So we're getting the odds on the left and odds on the right because both teams call only have two odds. And we're using a generator. This was a generator function, in fact, which we were yielding. And again, this was a for loop. We're getting each and every odd in each and every row. And after each row, we do a time.sleep. This is, or rather, after getting each row, we do a random sleep, which may not be necessary, but instead of instantly closing the browser. And then we move on to the if name, a loop of if name equals main, and we create a list which we'll be using to append our data and pass in our generator function to the variable data gen. And our URL will be betway.co.ke, and using the data gen function or generator function, we'll be getting each and every odd or each row of odd. And now we can run our program using the Python command. We don't have to append the Python.3 because we're in our virtual environment. And when creating our virtual environment, we used Python 3.10. And after waiting a while, you'll see the odd or the odds, depending on how many there were. In this case, there were only two odds, which have been generated as a list. So our next section will be dealing with Playwright, and just a small introduction to Playwright. So in this particular section, we'll explore how Python Playwright can be used to automate web applications on multiple web browsers. We will also discuss some web scraping best practices and advanced topics such as scraping images and performing text recognition. So in recent years, web automation and web scraping have become increasingly important in the world of software development. As a result, several tools and frameworks have emerged to make this process more efficient and effective. Two of the most popular tools for web automation and scraping in Python are Selenium and Playwright. So you might be wondering why Playwright is a little bit more favorable as opposed to Selenium. So firstly, Playwright offers a simpler and more Pythonic API compared to Selenium. Playwright's API is designed to be easier to use and understand, making it more accessible to developers of all skill levels. Additionally, Playwright is based on modern and more efficient architecture compared to Selenium, which can result in faster test execution and better performance overall. Another major Another major advantage of Playwright is the support for multiple web browsers, including Chromium, Firefox, and WebKit. And this means that developers can write tests and scripts once and run them on multiple browsers without having to modify their code. In contrast, Selenium has limited support for other web browsers, which can be a significant limitation depending on the specific needs of your project. Playwright also offers more advanced features and functionality compared to Selenium, such as better support for network emulation and geolocation testing. This can be particularly useful for testing web applications that rely on specific network conditions or location-based services. And lastly, Playwright is a newer and more actively developed tool compared to Selenium, and this means that it is more likely to receive regular updates and improvements, as well as better support and documentation overall. So, in summary, while both Selenium and Playwright have their own unique advantages and use cases, Playwright does offer a simpler and more efficient approach to web automation and scraping with better support for multiple web browsers and advanced features. So, moving on. So, we're now going to take a look at the installation steps. And the first thing would be to go to the Playwright website, the official Playwright website, which is playwright.dev. And of course, in this site, you do get the documentation. And as you can see, it is language agnostic. So moving on to the Python link, we have installation steps with pip install pytest playwright, and also playwright install, which installs all the web drivers, Firefox, Chrome, Safari, etc. And you can see basic examples on how to get started. And yeah, as you can see, it is a robust library. And just going through the website documentation, or the documentation on the website, you can see it's very similar to Fast API or Django REST Framework or Django Ninja, where stuff is type hinted. Where you can see the page, what you'll be getting is a page object, or rather, whatever the page will be has to be type hinted into a page object. So it is somewhat or mostly similar to Django REST Framework or Fast API. So looking more into you do have locators, just like other frameworks, which we'll be looking into in this section. You can also see you can perform asynchronous tasks as well by appending async and await in on the function and the getters respectively. So having done that, we can get started on the presentation. So Python Playwright, as we mentioned, is a Python library, or does have an extension for, or rather does have a Python package that provides a simple and Pythonic API around the cross-browser automation library. Playwright with Python Playwright, developers and testers can automate web applications on multiple web browsers, as we mentioned earlier, and the installation steps, as we saw earlier. Now, the pip install Playwright would be similar to the earlier installation we saw, or on the web page. And once the installation is complete, you can import the Playwright module in your application to initialize a browser context. So let's look at an example of creating a Chromium browser instance using Python Playwright. And the following code snippets. Snippet creates a new instance of the Playwright class. And once you have that, it then launches a Chromium browser instance without an actual browser. And this is because we passed in the keyword of headless equals false. And as I mentioned, we are using a new page, the new page method, as well as the new context method. So the next would be, once the browser context and page are created, you can navigate the page to the desired URL using the page.goto method to interact with the elements on the web page. You can utilize methods like page.click, page.fill, and page.wait for selector. So here is an example that clicks on a button and waits for the element to appear. And additionally, you can extract information from the web page using methods like page.title, .url, and .content. And here is another example that extracts the title from the web page. Printing it with key value. Now it is best to, when doing the scraping activities, to store your information either in a dictionary, and afterwards don't forget to close the browser, and you can close the browser context using the browser.close method. Now next up, we'll look at a practical example, really to get a practical understanding of Playwright. So the following Python program uses the Playwright library to extract data from Amazon's website. The program has a list of product ASINs, which are unique Amazon identifiers for products. The program launches a Chromium browser, creates a new context with a user agent, and then creates a new page object. It then loops through each identifier and navigates the page to the product URL. Now, using the page selectors, the program extracts the product name, stock availability, and price. If a deal price is available, it takes precedence over the regular price. The extracted data is then stored in a product tuple that contains the identifier, name, price, and stock availability. Finally, the program prints the product tuple to the console. Now, one limitation of this program is that it only works with the Amazon website and is specific to the HTML selectors used to extract the data. If the website changes its HTML structure or selectors, the program may not work as intended. In contrast, Playwright is a more versatile library that can work with a variety of websites and does have robust features as mentioned earlier. So let's get started. So the first thing we're doing is installing the PyTest Playwright as we saw in the website. And once we're done, we create our module. Before that, we have to install the Chromium Firefox drivers. Then, using the touch command, we create our Amazon Scrapy module, and we can get started. So the first thing is from playwright.sync p.api import API imports sync playwright, and this line imports the sync playwright function from the playwright Python library, which is used to automate interactions with web pages. We create a list of the identifiers containing four Amazon product unique identifiers. Now, using the context manager as with sync playwright as p, this line creates a playwright instance and assigns it to the variable p, and the with statement ensures that playwright resources are cleaned up properly after the code block completes. Now, the next line launches a Chromium browser instance using Playwright's launch method and assigns it to the variable browser. After which, the next line creates a new browsing context, i.e. a new tab in the browser with a custom user agent string using the new context method of the browser object. The user agent string specifies that the browser is running on a Mac with Safari version that and a Chrome version 112. Now the page equal context.new page. This line creates a new page in the current browsing context and assigns it to the variable page. Now the next is a loop that iterates over each identifier in the list that we created. After which the goto line navigates to the page, to the Amazon product page for the current identifier using the goto method of the page object. And the f-string syntax is used to dynamically substitute the current identifier value using the string. Now the next line selects the product name element using the query selector method of the page object and assigns its context to the variable name. After which the page.query selector, this line selects the product stock availability element using the query selector method of the page object and assigns its context to the variable stock. Now the next line selects the product price element using the query selector method of the page object, first attempting to select the deal price element and falling back to the regular price element if the deal price element is not found. The OR operator is used to short-circuit the logic and return the first truthy value, i.e. the first element that is found. So the conditional, this line checks if a price element was found in a previous step, and if a price element was found, the next line assigns its text content to the variable price. Now the next line assigns the text content of the selected price element to the variable price. After retrieving the price element using the page.query selector method, the program checks if the price element was found or not using the if price L statement. If the price element exists, it extracts the text content of the element using the text.content method and assigns it to the price variable. Otherwise, if the price element is not found, it sets the value of price variable to not available. Then the program creates a tuple named product that contains the identifiers, name, price, and stock information of the product as extracted from the Amazon product page. It uses the strip method to remove any extra white spaces from the extracted values. And finally, the program prints the product tuple using the print function, which outputs the information onto the console. And after processing all the products in the list, the program closes the browser instance using the close method. So once that's done, we can run our program, of course using the Python Amazon Scrapy using the Python command, and wait just a little bit, and we won't be streaming the entire list since during testing we surpassed our 3000 millisecond, or rather the number of requests for every 3 seconds. So we'll be outputting just one of the products in a tuple, and you can see that it is printed out to the console. And in this case, we have our price. The price element does not exist, so it prints, so it is filled with a not available string. And as mentioned earlier, we covered that in our conditional. So moving on to general best practices to follow when conducting web scraping. So when conducting web scraping, it's important to follow some general best practices to opt in our conditional. So moving on to general best practices to follow when conducting web scraping. So when conducting web scraping, it's important to follow some general best practices to avoid legal and ethical violations. So here are some best practices to follow. So the first point will be respectfulness. So do not overload the website servers with too many requests, and make sure to space out your requests and follow the website's robots.txt file, which outlines rules for web crawlers, avoid scraping websites that prohibit web scraping in their terms and conditions. Now use polite user agents. It is important to identify your scraper with a user agent string that accurately reflects your intentions. The user agent does allow website servers to identify your scraper and may impact the response time you receive. Using a generic user agent like Mozilla /5.0 is not recommended, as it may indicate that you are a bot. The next is follow applicable laws and regulations. Web scraping laws vary by country and region, and it's important to be familiar with the laws that apply to the website you intend to scrape data from. Collect only necessary data. Make sure that your scraper is collecting only the relevant data required for your intended purpose, and not more than that. Collecting personal info or private data without consent can be a legal and ethical violation. Future-proof your scraper. Websites are subject to change, so it's important to make sure your scraper is flexible enough to handle any changes to a website's layout, structure, or content. And lastly is test your scraper. Before running your scraper, test it against a small amount of data and ensure that it's working as intended. So with that in mind, we can have a brief look on advanced web scraping topics. So the following code, or the following example that we will look at in this section on advanced web scraping topics, will be processing. This code, the Python code, will demonstrate web scraping, which is of course the process of extracting data, and the code imports the requests and beautiful libraries, which are commonly used for web scraping, as we saw in earlier sections, and we'll send a request to the URL, which will be an example URL, and we'll be using the get method from the requests package, and we'll retrieve the response content and pass it to beautiful soup, which will pass the HTML code. The code will then search for the HTML for image tags using the find all method and extract the URLs of the images. It will then use the Python imaging library, or PIL, and PyTesseract libraries to extract text from an example image. Finally, the code will use the RE library to search for patterns in the text, such as strings containing only alphabets and spaces, and which are between 5 and 100 characters long. So let's go through a step-by-step, line-by-line analysis of the program. So, as mentioned, the first line will import the request libraries, which is used to make the request to the web page, and Beautiful Soup import class, or rather Beautiful Soup class from the PS4 library, which is used to parse HTML and XML documents. Next is we set the URL to script as www.example.com, wrap it in a string, and store the response in the response variable. Now the next line, the Beautiful Soup, which we pass in the response.context as well as our parser, will pass the HTML content of the response and store it in the soup variable. The next line will find all img tags in the parsed HTML document and store them in the imgs tag variable, after which we'll create an empty list to store the URLs of the images on the page. And next will be a loop which will loop through each of the img tags in the imgs tag variable, after which we'll extract the URL of the image from the source attribute of the img tag and store it in the URL variable. Now, the next line will append the extracted URL to the URLs list, after which we'll import the image class from the PL library, which is used to manipulate images. The next line will be used to perform optical character recognition, or OCR, on images. After that, we'll open the image file named example image.jpg and store it in the image variable. After which we'll perform OCR on the image and store the resulting text in the text variable. The next line will import the RE library and which is used for regular expressions. And the latter line, or the next line, sorry, will define a regular expression pattern that matches any sequence of letters, white space, or commas that is between 5 and 100 characters long. And the last line will find all matches of the regular expression pattern in the text variable and store them in the match variable, ignoring case. Now, you could, before compile your regular expression using the compile method and iteratively use it in multiple parts of your program. So that will be it for this section. Yes, thank you for listening.